freedomslips.com, the #1 listener-supported talk radio station, throwing ourselves upon the gears of the machine. Revolution Radio, where information never sleeps.
You called down the thunder, well now you got it.
Right, you tell them I'm coming, and hell's coming with me, you hear? Hell's coming with me!
Revolution Radio. The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Good evening, folks. This is Diamond with the Oppenheimer Ranch Project, bringing you a grand solar minimum update. No, we're not. This is the Inconvenient Truth, and I want to thank you for tuning in. Our guest tonight is on the line, and it's Jennifer Marohasy. I hope I said that right. Now, she has multiple degrees, including a Bachelor's of Science, a Doctor in Philosophy from the University of Queensland, and her most recent peer-reviewed publications from 2012 to present, they have been in the area of climate change. And we're going to be talking about a book she is the editor of tonight, Climate Change, The Facts, which came out in August of 2017. Now, Climate Change, The Facts contains 22 essays by internationally renowned experts and commentators, including Dr. Bjorn Lomborg, Matt Ridley, Peter Ridd, Willie Soon, and others that we love on our channel. So we're very pleased to have, do you call yourself Dr. Marohasy? But Jennifer Marohasy on the show. Jen, are you there?
Yeah, Jen's good.
Okay, good. So what got you, so you started off as a biologist back in the day in your early years, and what got you into the climate change dilemma?
I've actually always been interested in natural history, I guess. And, I actually did a botany entomology was my first degree, and worked as an entomologist for many years. Then worked for our sugar industry, and water was a big issue. So I got very interested in, I was actually always interested in rainfall cycles, and my father was always interested in long-range weather cycles. But then I guess with all the concern about catastrophic anthropogenic global warming and that it was never ever going to rain again, I started feeding data, particularly rainfall and temperature data, into artificial neural networks to see if I could generate rainfall predictions. So that's going back a few years now, but I mean, we are in the age of big data, so I was really just moving with the times.
And was the big data showing you that anthropogenic global warming was maybe a little bit of nonsense?
Well, what our technique shows, and as you indicated, we've got quite a few papers now published in the climate science literature. What it shows is the natural cycles persist, and you can use the patterns, the cycles, the neural networks, the artificial neural networks recognize the patterns and can use them to forecast rainfall months in advance. So we can go out 18 months. That work has not been at all popular because our Bureau of Meteorology here in Australia keeps on saying, well, the patterns and your system might be working today, but it's not going to work tomorrow because of elevated levels of carbon dioxide. That means that the system's not going to work into the future, and they've been saying that to us now for 6 years, and really making it difficult for us to move forward with the commercialization of the technique, because, of course, central to to their method, I think their failed method using general circulation models is the idea that climate's on a new trajectory, which there's no evidence that that's the case.
Yeah, and I love the fact that over about the last decade, by the way, let me just qualify myself. I come from a paleoclimatology background. I taught at university back in the 90s, and we were well aware. We were working on the Milankovitch cyclicity, and we had access to the GISP2 data and the ice core data, and we were unraveling the multivariate forcing mechanisms which were causing the climate cycles. So we've known for decades that there are many forcing mechanisms involved, and the simplification of the current models is embarrassing. It's non-scientific, and it's based on zero fact.
What you did mention in the introduction about this book we're going to talk about today, I mean, the extent to which the IPCC keeps on changing the story with respect to the long-range, temperature, like they say that there was a medieval warm period when they first put out their assessment report back in 1991, and then, of course, the third assessment report has no medieval warm period. So the extent to which they keep rewriting history is quite extraordinary, isn't it?
It's amazing. Well, I'd like to start at the beginning. We shared the introduction to your book with a number of people, and I found it fascinating, this paragraph that you sent, the very beginning paragraph, because it's a sign of the times. And I'll just read it to the listeners that hadn't read it. There are certain things best not discussed with neighbors over the fence, at barbecues and at gatherings of the extended family. They used to be sex and politics, but more recently, climate change or global warming has become the hot button. I mean, it is insane. Can you delve into it a little bit about that topic?
So yes, in the introduction to the book, I talk about how you used to exclude sex and politics from discussion at family gatherings, but now it is climate change. That's certainly the situation in my family at Christmas time. One of the members of my family always says, Jen, can we not talk about climate change because you know too much about it? I mean, how embarrassing is that? It's not because I'm emotional about it or anything else. It's that I know too much about it, so the others feel that they're not likely to win the argument with me. Anyway, I respect their perspective, so we tend not to discuss climate change at gatherings with my extended family. The point there is that so many people, I guess, hold strong views based on this concept of a consensus, based on the idea that it's the right thing to be concerned about catastrophic global warming, but not because they understand the issues, not because they're concerned with the evidence. And it is embarrassing. I think that we are at a point in history where reason and evidence is taking a back seat to fashion and consensus views.
Yeah, it's unfortunate, and there's a lot to unravel as far as what's happening in the scientific community. And what I mean by that is indoctrination. So the students that are being taught by the professors now that have tenure or are getting tenure, they're actually not being introduced to the climate cycle model. Now, I find it hilarious, being a professional climatologist, that I'm called a denier of climate when my entire background is based on understanding the nature of climate cyclicity and how it ebbs and flows and goes up and down and the forcing mechanisms associated with that. There is no other evidence that exists except natural climate cycles. And that's the second part of your intro. So could you give us your point of view on natural cycles?
Well, of course, fundamental to the climate skeptic's perspective on climate change is the fact that there are natural climate cycles. We don't deny climate change.
No, we don't.
We don't deny climate change. What we say is, and I think all the contributors to this book would simply question the contribution. Some would say that there is a discernible human impact on late 20th century warming. Others would say that there's not. So it comes down to whether the rate and magnitude of climate change over the last 150 years falls within what would be expected naturally. Now, many of the contributors to this book would say that even the last 10, 20 years of warming, it's perfectly within the rate and magnitude of what you would expect to occur, even if even if there was no industrial revolution, what you would expect to occur naturally.
Yeah, and it's true. If you go look at all of the data sets, we are within the natural variability expected in the climate cyclicity, especially since we are exiting out of a cooling period, being the Little Ice Age starting in the 1300s, followed by the Dalton minimum, which just ended in the 1800s. So the only thing we can be doing is warming. Why humans have to be responsible for that is beyond me.
There are cycles within cycles, and you mentioned the Milankovic cycles, the 41,000 year, 100,000 year cycles. But and yes, I would agree that coming out of the Little Ice Age, we've got a general warming trend, though there are cycles within that. So, for example, in chapter 3 of the book, Dr. Nicholas Scaffetta talks about how you can actually find the 9.3 year cycles and the 60 year cycles. So, for example, when I actually look at the temperature records for pretty much anywhere in eastern Australia, our hottest years were actually back in the 1930s. That's if you look at the unadjusted raw temperature data.
The same
and
year
I think
in North America, 1934 is a hot year.
Yeah. So a little bit later in Australia, unadjusted, the summer of 1938-39 was just an extraordinarily hot year in Australia, and still sets the records for places like Sydney. Despite the growth of that city, the hottest day is still 14th of January 1939. So there is there are cycles within cycles, and if we're going to be able to forecast droughts and floods and be prepared for the next ice age, we need to understand the cycles rather than be preoccupied with carbon dioxide.
Right, which we can see from the ice core data is following the temperature, and it probably is not a driver, especially when we consider the concentration as a greenhouse gas. And the fact that cloud cover is probably thousands of times a stronger driver of climate on Earth than carbon dioxide ever will be. And the work of Svensmark and cloud nucleation and cosmic ray flux, that is the cutting edge science that's going to help in these layers of cycles that we need to unravel. Also, your computer learning software is absolutely where we need to be, because there has to be this, it's so much math involved. We need to use computer models, just not the linear ones that the alarmists and the warmists are using that don't even consider real data.
That's right. There are so many different variables, and there is reference in Chapter 3, Nicholas Scaffetta's chapter, to the effect of the planetary orbit, how that moves the barycenter, and then these electromagnetic oscillations and how they affect cosmic ray flux. It's all complicated. It's all interrelated. And I really do think that if there was sufficient funding and effort to support our work using big data, machine learning, artificial neural networks, we could make a lot of progress, a lot more progress than John Abbott and I have made over the last few years.
Yeah, and I believe that the problem that's occurring now is in funding, because you have to be using the linear IPCC alarmist model in academia to get the funding, and so there's no real climatology work happening. It's all dogmatic puppetry.
You know, it's impossible. I've been excluded from a couple of universities over the last few years, and we don't need to go into that on this program. But it is very nasty. The extent to which people seek to exclude us because we're looking at using a completely different technique to mine the natural climate cycles. I think what I find a little bit upsetting is the extent to which actually many skeptics will acknowledge that we have cycles, and they will acknowledge the long-term cycles, but they will actually deny that they are useful for forecasting weather or for forecasting monthly rainfall, which is what I do. And they're not keen to understand a lot of the work that has been done, for example, on lunar cycles and how that can affect can affect the timing of rainfall, but also the amount of rain that falls, and also affect global temperature. And chapter 4 of the book is about the moon and how it affects the weather on a daily, monthly, and also 18.6-year cycle. I'm not sure if you have put much time into understanding lunar declination cycles, and I can see the correlations with that and the satellite record. Have you looked at that very much?
Well, the work of David Dilley is extensively into those lunar cycles, and it correlates directly to the AMO and the PDO, the Atlantic Multi-Decadal Oscillation, and the Pacific Decadal Oscillation. So there's definitely a lunar driving mechanism to ocean currents and ocean temperatures.
That's right. And if you look at, or if you think about Roy Spencer's work with the satellite record, of course, you can see that there was a spike in global temperatures back in 1997-98, and then another one in 2015, 2016. Now, that corresponds exactly with minimum lunar declination, that 18.6 year cycle. And the only person I know who forecast the 2015 to 2016 spike in temperatures is the fellow who wrote chapter 4 of our book, Ken Ring. He forecast that temperatures in the northern hemisphere that winter would be very mild because of the lunar declination cycle, the 18.6-year cycle, and that was a major contributor to what appears to be the spike in warming when you translate everything into a temperature anomaly. Does that make sense?
Well, it's fun to do science live while people are listening, yes, and man had nothing to do with it. So it makes absolute sense.
Well, the Michael Manns of the world have basically said that temperature's just going to keep going up, whereas if you listen to the Ken Rings of the world, they'll say that you have these cycles and that the 97-98 Super El Nino corresponded with a minimum lunar declination. Then, of course, we had the pause, and then we had another spike, and that corresponded 18.6 years later with another minimum lunar declination. The problem with the satellite record is that it only goes back to 1979. If it went back further, we'd know whether that correlation holds for more than 2 cycles. As long as they don't close down Roy Spencer's work, which I know they've been talking about doing, we should be able to see in another 20 years' time whether there's another spike there or not, which correlates, and then maybe even your lukewarm skeptics will start to recognize that you have to think about the orbit of the moon around the Earth around the sun to understand global temperatures.
Well, based on my studies in paleoclimatology, I believe we're at the end of the interglacial, and this grand solar minimum is going to be... So the work of Roy Spencer, that graph, which has dropped 0.6 degrees C in the last 2 years, is going to continue down for quite some time, and we may drop into another major glacial cycle for thousands of years, based on the past 4 interglacial data.
I think that may be, I won't disagree with you, but that may be the long-term trend, but I think that there's going to be the cycles within that. So in another 17 or 16 years, we may get another little bit of a blip up.
So here's what my question is to you. We're talking about the natural variability and why everyone's panties are in a bunch over the little bit of warming since 1850, and we can just talk about, like you pointed out, the Milankovitch cycle, the 41,000-year obliquity cycle. That averages a 10 degree C change on Earth every 40,000 years. I mean, that is an average change. If we're talking about a 100 kiloyear cycle, there can be up to a 23 degree C change on Earth. And we have this clear ice data going back about 1 million years, which shows this, which anyone can go see and look at. Every 100,000 years, the temperature on Earth goes up and down 20 degrees C. And within those, there's smaller cycles, the precessional cycle and the obliquity cycle, which cause perturbations in the 10 degree C range. So why is everyone scared about 1 degree C or 2 degrees C? Who cares?
Because, and I've had these discussions with our Bureau of Meteorology, trying to convince them to support some work on using big data and neural networks. They say because of current levels of carbon dioxide and going right back to the work of Svante Arrhenius, we are going to see this. Well, if you go back to 1896 and the work of that chemist, which sort of started off this obsession with the effect of carbon dioxide on temperature, he proposed that you would have a 5 to 6 degree increase in temperature with a doubling of carbon dioxide. The IPCC is now talking about a 3.2 degree Celsius increase in temperature. But if you look, I think the most important chapter in our book, and I am jumping ahead a little bit here, but I think it's chapter 19, which explains why even their physics is wrong. So they deny the climate cycles, but then they actually get the physics wrong. So I don't know if you want to talk about that now, but there's a whole lot of issues in terms of how the IPCC understands the physics of carbon dioxide and how they essentially exclude water vapor from the from their calculations.
Yeah, well, that is crazy. Being that water vapor is 90 times more prevalent than CO2.
Yes, and as far as I can understand, the only reason why they say they don't deny that water vapor is a greenhouse gas, but what they say is that it's not long-lived, and because it varies with altitude, latitude, and all sorts of other things, it's very difficult to model, so let's exclude it.
Hey, let's exclude 90% of what's controlling the climate.
Yeah, to make the models simpler. So there's a huge problem with the physics in the IPCC models. Now that they basically incorporate the Svante Arrhenius's concepts, which, as I said, date back to 1896, which were theoretical. And then in the 1950s, 60s, and 70s, we had the development of all these spectroscopy techniques, so people could actually start to get a handle on the interaction, I guess, between carbon dioxide and water in terms of radiative physics. And so you've got this enormous literature relating to that, and the work of a fellow called Jack Barrett, explaining that, well, you can have all of the theory, but if you actually look now at the experimental work and what climate sensitivity is likely to be, it could be as low as 0.3 degrees Celsius, right? So you've got the general circulation models talking about a 3-degree increase, and then you've got this experimental work talking about a whole order of magnitude less. And yet all of that work published in the peer-reviewed literature since the 1980s is denied by the mainstream climate scientists.
Right, but the facts are in. If every country stuck to the Paris Accord, we could barely alter global temperature by 1/100th of a degree C. That's 0.01. So why would we even go into the Paris Accord? Why all that nonsense?
Well, so chapter 15, which is by Bjorn Lomborg, and I chat with Bjorn every so often, and he does like to just not get into the physics and not sort of query their modelling too much. So what he does is he accepts all their assumptions, and then he basically explains how even using their models, accepting their assumptions, as you said, adhering to the Accord is going to be very expensive while hardly affecting the global climate at all.
I think it would actually affect the global population in terrible ways. This cabal of environmentalists and alarmists, I used to be part of the group coming from a university. You can imagine 30 years ago, I didn't want to pollute, was a part of recycling and all that stuff. And now I live on a ranch and I'm starting this sustainable life where we're putting in permaculture farms and using geothermal. And everyone could be doing this type of, natural living that doesn't affect our biosphere. It's good for the planet, but it has nothing to do with global warming. Carbon dioxide is plant food, and this is now proven. Why aren't the masses picking up on the obvious ruse that is going on?
I think it all does, actually. You're talking about, energy, and you've obviously got some new techniques for generating. Are you generating your own electricity on your ranch?
Yeah.
Yeah, and that's great. But maybe in India, and I was just in Kenya earlier this year, we shouldn't deny people what has proven to be effective in terms of cheap, reliable source of baseload electricity, which is coal. Now, the campaign against coal and then subsidies for alternative energy sources can actually be traced back to Margaret Thatcher in the 1980s, when she actually set up the climate research lab at the University of East Anglia. And I was talking to some conservative skeptics a couple of months ago, and they really didn't like me saying they didn't dispute that it was energy politics and the associated value of that at a national level and a sectorial level that was driving a lot of this nonsense, but they didn't like me suggesting that it was Margaret Thatcher attempting to break the unions in the UK back in the 1980s that perhaps started some of this. So anyway, none of that's in the book, but
we had Dr. Tim Ball on last week, and I don't know if you, I'm sure you know him. The conversation we had was enlightening, to say the least. The man is a wealth of knowledge of the behind-the-scenes working of the insanity that we're now living today. And so part of that is the Great Barrier Reef. Now, being on the Northern Hemisphere, we get flooded in all of the headlines about all the dying reefs. Now, being an invertebrate paleontologist, dying reefs have been happening for hundreds of millions of years, and there is nothing strange about reefs dying today, because as climate fluctuates, sea levels change and biospheres move. It's what all paleoclimatology is based on. And we've had reefs catastrophically eliminated dozens of times throughout hundreds of millions of years, and they always recover. It's one of the most resilient sea creatures, the reef complex. And so now we have the alarmist money being funded to this nonsense acidification and bleaching campaign that's going on down in the Great Barrier. And at the same time, there's a group of scientists that are actually publishing papers that are saying, no, it's normal. This is all, what they are saying is a lie. So what's the truth?
So we actually start Climate Change, the Facts, 2017. This is the book that I edited, that I'm keen for your listeners to go out and buy. So if they Google my name, Jennifer Marohasy, and Climate Change, the Facts, 2017, they can get the book from Amazon's and Connor Court Publishers and Booktopia and all sorts of different places. We've already sold over 10,000 copies, which is great. Now, the first chapter in the book.
10,000 more on this show tonight alone. There'll be a link below for all you guys listening, and we're going to put this up on Facebook, and we're going to have it on our YouTube channel, and it's going to be everywhere. So you'll be able to just click the link and get the book. It's $33, free shipping. Done. Go ahead, Jennifer.
Thank you. So the very first chapter in the book is titled The Extraordinary Resilience of Great Barrier Reef Corals and Problems with Policy Science. And that chapter is written by a fellow called Peter Ridd. Now, when he wrote this chapter, he was a professor at James Cook University who's worked for 30 years on Great Barrier Reef issues, particularly in the water quality sediment area. So he's extensively published on the issue of the Great Barrier Reef, and including, actually more recently, coral calcification rates, because he started looking at coral calcification rates when these published papers started coming out suggesting that with the increase in water temperature, we had a decrease in calcification rates. And he said, well, that doesn't fit in terms of the earlier literature. Then he went and had a look at some of the work done by a fellow called Glenn Death, and established that in actual fact they weren't comparing apples with oranges, if you like. The early work with respect to coral banding were done on younger colonies of coral. And so Peter went and published that work showing that actually if you look at coral banding widths from colonies of the same age, we've actually got an increase in calcification rates, not a decrease in calcification rates. Now, all of that's published in the peer-reviewed literature. I asked if he could do a bit of a review of that for Chapter 1 of our book and look more generally at resilience or not of coral reefs, and also, I guess, look at, because this is sort of where Peter's gone in the last few years, funding of science, and how it's not the evidence that's coming through, how we've got this crazy stuff being published because it's being driven by funding and inadequate quality assurance. Now, all of this is detailed in Chapter 1. Peter then came on television with me in August for the launch of the book, and he was really very upfront in his comments. What he basically said was, we need more quality assurance because a lot of stuff now being published in the peer-reviewed literature about the Great Barrier Reef is fundamentally flawed in terms of its methodology, and that you can't necessarily trust the work of some of these scientists. He was subsequently censured for that. He didn't accept the censure, and he was sacked earlier this year. And I've been helping him fundraise because this is all going to court now. So we're slightly off the topic of Great Barrier Reef science, but if your listeners...
to that, because Professor Peter Ridd does need our help. I'm well aware of the fundraising effort for his court battle, and we did have Dr. Tim Ball on, who has had to shell out over $600,000 to defeat Tin Man and his hockey stick. So, you know, our listeners are keen on Googling Dr. Ridd and finding his, I believe it's a GoFundMe, and donate some money to the effort.
So what happened was we needed $90,000. That was Australian dollars, a little bit less in US dollars. And we actually ran that campaign supported by Anthony Watts, and we raised that money in 48 hours. Then that was when he was censured but not sacked. Then we needed another $170,000, and we've raised that again with the support of Anthony Watts, Benny Pizer, and Joe Nova. So we don't actually need any money at the moment. The GoFundMe, so if people Google Peter Ridd, R-I-D-D, and GoFundMe, they'll see that we've raised all that money, and I was actually listening in the federal court on Monday. There's going to be an initial directions handed down tomorrow. So the case has just started. We've got enough money right now, but I'm hoping I'm not going to be coming back on your program, or maybe Peter could come on your program if we need more money in a few months. Hopefully that's not the case. But what's great about Peter, what's great about Tim Ball, is that they're actually moving forward. They're standing up for the truth. Now, this has come at huge cost for Peter. He agreed to write the chapter for me for this book. He then went on television and he explained it in plain English, and it's caused him to be sacked. He could have just gone away, but he's decided to fight it, and it's just tremendous. But, you know, I was just seeing all these affidavits and all the nastiness that's, of course, associated with these court cases. And in the case of Peter Ridd, it's just started within the federal court in Brisbane, in Australia, on Monday.
Fascinating. Well, we're glad you have the support you need moving forward.
Thank you.
Yeah. So let's talk about more about the economics of climate change. And it goes back to Margaret Thatcher, but the funding issue is the main point, and that's what all he's pointing out. So Dr. Ridd just pointed out that the science is flawed because the people, I mean, if you come out with a salacious report, paper, and you submit it to a journal that's looking for this amazing global warming piece, they will eat it up. They're not going to check your sources. Typically, they're going to be like, oh, this is great.
Well, in Chapter 2, which is about ocean acidification, so the first chapter is about the Great Barrier Reef and its extraordinary resilience, and Chapter 2 is about ocean acidification, and it starts off talking about, you may not realize, but less than 20 years ago, there were basically no papers published in the peer-reviewed literature on ocean acidification, okay? Now we've got about 800 papers a year. And the people producing those papers, they're reliant on government funding, almost all of them government funding, to produce these studies. And if they don't conclude that we've got a problem, I can tell you they're not going to get funded next year. So there's this whole industry around, you know, just something as small as ocean acidification. Okay, ocean acidification, you can say it's a huge problem because, you know, most of the earth is covered in ocean. But the reality is when you actually, and in chapter 2, John Abbott and I go through the evidence for ocean acidification, you see that you've got tremendous variability in pH. Say, for example, just within one reef on the Great Barrier Reef, much greater variability in pH in terms of your diurnal cycle than you've got in terms of what they can measure anywhere in terms of the longer-term cycles. There are longer-term cycles, there are diurnal cycles, but, you know, when you look at the evidence, when you review the evidence, in terms of these ocean acidification papers published over the last 20 years, there's no catastrophe. The only catastrophe is when they actually tip hydrochloric acid into some of these tanks where they're trying to get a difference, you know, where they're trying to generate an effect. And then, of course, yeah, you can reduce your pH, and it can be catastrophic for the little fish and the little corals in those tanks.
Yeah, so what they're hiding through fraud is that the natural variability in pH is greater than the human-induced variability, and there is no problem. And that's going all the way back to the homogenization problem when they started tampering with data. So they've been tampering with data for decades.
Well, in terms of the situation, so you've got issues, I guess, just to sort of finish off with this issue of ocean acidification and the Great Barrier Reef. When you actually do the studies on the reef proper, you can see that there's variation in pH, and there are cycles, but there's no general long-term decline in pH. But when you do your little small-scale studies in the laboratory and then feed the results from them into computer models, you get a result that can make a nice newspaper headline. Then there's this issue of, they don't use the term homogenization in any of that work, but the term homogenization is used extensively in terms of generating a global mean temperature. And there's a few problems with how global mean temperatures are generated, but it does relate to, I guess, playing with the data and to some extent sleight of hand. We've got several chapters in the book on the issue of temperatures, how they're calculated, and how the temperature record at any one place. For example, in Chapter 9, I talk about a location called Rutherglen in Australia, how temperatures at Rutherglen, which has just got a beautiful record in terms of all the quality assurance issues, doesn't show warming, but how if you homogenize data from all these places, and what they do with the Rutherglen record, that before they add it with all these other heat island affected records and all these other ones, is they make all these adjustments, they do all this remodeling so that they can generate this 1 degree plus warming per 100 years. Do you want me to talk about Rutherglen, or maybe we could start with Anthony Watts' Chapter 5 is about the US temperature record and problems with the heat island effect and how the adjustments actually add to it. They exacerbate rather than correcting for it.
Yeah, exactly. So heat island effect causes temperatures to rise. Also, NOAA claims to have monitors in places it doesn't. So a lot of their global maps show it above average in places that there is no data. So how they make those conclusions is beyond me. But homogenization used to make milk safe, and now it's used to make global warming happen. So let's talk about it.
So Anthony concludes his chapter by saying that, he opens and then concludes the chapter by basically saying that there are potentially problems with using the raw data because of the urban heat island effect, and because sometimes they open stations here and they close them down and they move them over there. So maybe a solution will be to calculate temperature trends from unperturbed stations, specifically stations that have a long record, no moves, no equipment changes, no time of observation changes, and free of nearby infrastructure encroachment. So he says maybe we should be looking for those types of stations. And that's what I've actually done in Australia, because if we just go back to what's sort of driven a lot of my work, which is wanting really good temperature and rainfall data to feed into my arrays for my artificial neural network. So what I'm always looking for is really long temperature series that are very high quality. So in Australia, one of our problems is that going back to the 1860s, 1870s, 1880s, temperature stations were established in northern Australia, even with Stephenson screens, with mercury thermometers, recording at all the right times, and taking, just recordings for, consistently for decades. But then what happened in the 1960s and 70s, 80s even, and through to the 1990s, these recordings were taken in the yards of post offices. And so not only did you have the growth of the town around that post office centre, but you also then had those post office recording centres closed down, and the weather station moved to an airport, which is obviously a very different environment. So you have these discontinuities. So initially recording at a post office in an urban environment, and then moving the weather station to an airport. But there are some places in Australia, and Rutherglen's one of them, where they established a weather station in a rural environment. For example, at an agricultural research station. So Rutherglen, they established a weather station, an agricultural research station, and it's still recording to the present. So you don't have the problem of urban encroachment. You don't have the problem of the move from the post office to the airport. You just have this beautiful record, essentially from, for example, 1912 through to the really good records through to 1997. I'll explain why there's a bit of a problem after that. But basically, what you'll see with this really high-quality record is that in terms of the minimum temperatures, not only is there no warming, there's actually cooling in the record. And this is the same when you go to other sites in southeast Queensland, rural sites. And this is because we've actually had land use change. So the hottest, if you take Rutherglen, and we look at it in terms of maximum temperatures, it's pretty flat, but the standout hottest summer was 1938-39, and that's pretty much everywhere across the east coast of Australia in terms of maximum temperatures. If you look at minimum temperatures, you actually got cooling. And the Bureau and the mainstream climate scientists can't deal with this. So you've got a beautiful temperature record in terms of how it was measured and where it was measured and everything else, but the minimum temperatures show statistically significant cooling. And they go and adjust it, they remodel it, because they just can't cope with that reality. Now, we can talk about why there's cooling in the record and how it relates to land use change and how they want to deny that, or we can talk about something else. But it's extraordinary the lengths they will go to when they've got absolutely no excuse for making any adjustments. They still go and do it because the trend does not accord with expectations, does not accord with theory.
Yeah, well, that's fraud. Now, how many stations like that exist in Australia with an unadulterated, continuous 100-plus year run?
So we've got some lighthouse records that are beautiful like that, and then we've got some rural records. We don't have a lot, but they tend to tell the same story. Now, the records from the lighthouses tell a slightly different story from the records from the inland rural sites, and that's because the lighthouses are probably reflecting sea temperatures a little bit more, whereas the inland records are reflecting a bit of land use change, which has been improvements in land use, irrigation into the environment, and of course when you bring water into an environment you tend to find that that there's cooling. And I understand people have looked at this in other parts of the world and found similar trends.
Well, yeah, of course, if you take a desert like we're doing here and you use restoration agriculture and you start to build soils and retain moisture, the surface is cooler. That's a no-brainer. It's based on science. And then when you get plants to grow, it gets even cooler.
So that's right. And see what happened with our earliest agriculture, which is where our first weather stations were established in Australia. A lot of that was in the southeast, in an area known as the Murray-Darling Basin. So into places like Rutherglen and Deniliquin, initially you had sheep, you had stations, and you had vast areas, and you had thousands of sheep grazing, and you actually had people that didn't appreciate the extent of the cycle, so they got caught out, and you had dust storms, and you know that followed the drought, and you had scorching hot days, and you had extraordinarily hot temperatures and bushfires through the 1930s and 40s as well. So you had these extraordinarily hot summers. And then starting in the late 1920s, but not really gaining a lot of pace into the 50s and 60s, you had dam building. And now Rutherglen, while it was once sheep stations, that area is now vineyards. And so you've got a completely different... So the Rutherglen Research Station land use change hasn't gone from sheep to vineyards, but the surrounding area has that research station, and the paddock that the screen is in is still dryland winter pasture, but the surrounding area, the gigaliters of water that have generally moved into that area and that are now held for rice cultivation, vineyards, canola, so many different things. So there's this general impression, and Jared Diamond's written about it, how land use change has deteriorated. Across Australia it hasn't. There's generally more water in the landscape now, and the landscape is generally better managed. The late 1800s we had dust storms. The 1930s and 40s we had terrible dust storms. We don't have them anymore. We don't have them anymore in the Murray-Darling Basin because of improved land use management because of just the sophistication of the farmers and their access to water, particularly in periods of extended drought.
Yeah, I believe that's the key to the future survival of the planet, is going back to natural farming techniques that retain water, biodiversity. The monocropping that's done throughout North America here in the U.S. is, just killing the biome. It's disgusting. It's unnatural. And natural farming is typically more abundant, more part of the natural cycle, and retains more water, moisture. And as you're finding, actually is cooling the planet in those regions.
Well, it's quite interesting because a lot of, if I can call them armchair environmentalists, are against some of the irrigation practices in the Murray-Darling because they say that the water always used to run out to the sea, and they don't like agriculture and irrigated agriculture, and they say, well, all the water should just run out to the sea like it used to. But it didn't used to. It used to spread out. It used to come down off what we call our Australian Alps that aren't that tall in the scheme of things relative to your mountains in the States. But the water used to come down with the snowmelt, and it used to spread across, which is why those plains are so thick in terms of beautiful soils. So the water used to spread across, and it does now, but in a much more controlled way. Now, the Murray-Darling's only about 14% of the land mass of Australia. We still have a lot of areas that are free. Sure.
We're about to go to commercial. We're going to come back. We're talking with Jennifer Marohasy, the editor of Climate Change: The Facts, which you can get on Amazon right now. Kindle, $9.99. It gets 4 stars. Do it. We're going to be back, and we're going to talk more about the facts of climate change 2017. Stick with us, Jen. Put it on mute, and we'll be back in about 5 minutes.
Thank you.
You're listening to Revolution Radio at freedomslips.com, and we'll be right back after this message.
Enter into a world unseen on Raven Star's Witching Hour. You will encounter eclectic topics from the realm of spirit brought into our matrix of truth. With your host, the Solaris Blue Raven. Solaris will bring you an array of unique guests covering topics from ghostly spirits to amazing anomalies, covert technology, UFOs, and shadowy global events.
And that's right here at Revolution Radio, freedomslips.com, Saturdays, midnight till 2 a.m. Eastern Time. Revolution Radio, where information never sleeps.
Let the magic rise.
Join me weekdays for my new show, Tell Chris Joe. It's going to be a problem show brought to you live from Kensington. Thursdays, I'm dealing with hot topics, heated debate, what's new around the world, and ring-ins to discuss listeners' problems and offering considered and heartfelt solutions. So join me, Chris Hart, for Tell Chris Joe. Stop what you're doing, grab a cup of tea. I'm coming live from Kensington. Relax. Let me entertain you with a coffee bar online. Listeners' very personal problems. So that's Thursdays, 2 p.m. in the afternoon, Revolution Radio, freedomslips.com. See you there. It's going to be lots of fun.
This is Barbara DeLong, host of Nightlight Radio, inviting you to join me on a cosmic journey, exploring a metaphysical montage of spiritual material, covering everything from the mundane to the magical, UFOs to unicorns, and everything in between, including spiritual readings for those who seek enlightenment. Let Nightlight provide you with equal measure of light, love and laughter, insight, wisdom, and inspiration. Monday nights, 10 to 12 p.m. Eastern, right here on Studio B, Revolution Radio, at freedomslips.com.
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Welcome back, folks. This is Diamond from the Oppenheimer Ranch Project. This is the second half of the Inconvenient Truth with Jennifer Marohasy, editor of Climate Change: The Facts, 2017, which contains 22 essays by internationally renowned experts and commentators on the facts about climate change, not the dogma. We were just talking about unadulterated climate records from Australia, and I don't know if you're aware, Jennifer, we've had a show. It's almost a year old now. We have a lot of followers, and it's because I've come from an activist background in the last decade. I helped start the March Against Monsanto almost a decade ago, and then I actually ran into trouble with this multinational corporation following me and blocking me, and I had to leave the East Coast. So I came out here to the mountains to hide, and the first thing I did was get back into activism and spewing the truth about the climate on Earth and the nonsense I was reading in the mainstream media. And now the bomb, I'm so far away from them. I know so much about the bomb on the other side of the Earth. It's insane because they're one of the number one perpetrators, as well as NASA and NOAA, of the global warming hoax. They almost invented the term homogenization with all their fake temperature graphs. And you're revealing to our listeners how global cooling is actually occurring simply by changes in land use when you actually look at the data. So the science that we're experiencing currently on Earth is so far from the truth that we really need a global reset. And I don't know how that's going to happen, but it seems like more and more people are cluing in on the fact that this global warming ruse is a ruse because the variability is becoming clear. Now let's talk. Can you talk more about the bomb? And well, let's first talk the bomb prediction. It's going to be the warmest winter ever, and they're already failing at that, and it's barely winter.
So the bomb in Australia is the Bureau of Meteorology, and
definitely not the bomb.
So, in terms of your listeners would be familiar with the ClimateGate emails, and there's a fellow, of course, there's Phil Jones, who features in the ClimateGate emails from the University of East Anglia, and then there's David Jones, who features in the ClimateGate emails, and he's from our BOM here in Australia, and he actually says in one of those emails that drought's so bad and temperatures are warming so much that you don't need data anymore. He actually writes that in an email.
It's that we're all up, so it's over.
So and David Jones has been at our Bureau for a very long time, and like Phil Jones from the University of East Anglia and Michael Mann from your country, they are very committed to this theory of catastrophic anthropogenic global warming. And for a period there, temperatures were rising, but as we've already discussed, you tend to get these cycles. So, you know, they can cool and then you can get land use change. So, you know, that negates some of the warming that might have occurred to the extent that you end up having cooling in your minimum temperatures. Anyway, this all makes it very difficult to report year on year that temperatures are getting warmer, which is what a lot of these activist climate scientists want to be able to do. So they started homogenizing the data going back some years, which is basically remodeling the raw measurements. So in the case of the Bureau, they keep two data sets. There's the There's what we call the CDO data, the climate, which is the archive data, and then there's what we call the ACORN data, which is an acronym for the remodel data, but basically they never call it remodel data. They just say this is the official data set, and they take the temperature series from places like Rutherglen, and they remodel them for a whole lot of no good reasons, and they show
global warming reasons. Let's be honest, it's for global warming alarmist reasons. That's what it's for.
I think, and in the end, there's a lot of money sitting behind this issue of energy politics and sectorial and national interest when it comes to energy. But there's another thing that the Bureau do, which I don't actually know is a big problem in the States. What the BOM have done is because they said that Rutherglen's good up to about 1997. Now, around about and since then, because it's been an incremental change, they've been replacing the mercury thermometers and that measure maximum temperatures in what we call our Stevenson screens, our weather stations, with electronic probes. And this is a completely different way of measuring temperatures. Now, none of this is in the book that we've been talking about, but it's a fairly important thing for your readers to maybe know about, and I've written a fair bit about it on my blog, jennifermarohasy.com, and that is that in Australia, well, it's happened in the States as well, but in the States, you've had a move from mercury thermometers to electronic probes, but your authorities, your institutions average the 1 second readings from the electronic probes over a 5-minute period to then come up with the minimum and maximum temperatures for each day. In Australia, our Bureau started taking 1 minute averages, and a few years ago it stopped doing that, and it now takes 1 second spot readings and uses them as the maximum temperature. So for the same weather, Australia is breaking all sorts of records at weather stations across the country as they incrementally move from mercury thermometers to electronic probes. Have I explained that clearly enough?
Yeah, so they're specifically manipulating the data by putting new probes in, which will definitely read high because they're actually taking the high of an average, which of course is going to be a record every time because it's based on an average. So if
they're not taking an average. They should be taking
number. Yeah,
they're not taking the average.
They're not. So they're taking the high end, which is always going to beat the average, which is why it's always a record.
So the mercury thermometer had a bit of inertia in it. So it never got that, that spike that could be from an aeroplane exhaust, for example. Whereas what they're doing now at, for example, the Mildura Airport, where I've written a little bit about this, is instead of averaging the 1 second readings over 1 minute, which is World Meteorological Organization standards, or what you do in the States is over 5 minutes, because you want your readings today to be comparable with the mercury thermometer readings. So they say you need to average. So what the Bureau does is it's not averaging anymore. Now, this is not controversial. It's just nobody's reporting it because it's just too extraordinary. The Bureau acknowledges that it's not averaging, except it's saying that we're using custom-made probes, so we don't need to average because they exactly mimic the mercury thermometer. So we're saying, well, can you show us the data to support this? And the reports that show us that the readings now from the probes are equivalent from the mercury thermometers, and they're refusing to do it. And so there's a big fight between a few of us here in Australia and the BOM over the fact that they won't release the reports that show that the measurements from their custom-made probes are equivalent to the mercury thermometers. Now, this is outrageous because Australia is a fairly large landmass, so we've now got basically problems. So we've got problems with homogenization, but putting all of that aside, since they started transitioning to electronic probes and taking these spot readings, we've actually got problems with the raw data, which is being gathered up by NOAA and your Goddard Institute for Space Studies. Yeah, we've got really major problems.
You have digital data being gathered by digital frauds in the name of NOAA and NASA, which are digitizing it, and they can make it look like anything they want. I've seen sea level change up and down. It was dropping for the last 3 years. Now it's been going up for the last 3 years. It's an absolute manipulation to feed the narrative of the mainstream. Now, whoever this group
They wouldn't
get
it past the Guinness Book of Records. If they tried to get their new record, Hot Days in Australia, into the Guinness Book of Records, they'd say no because your measurement system is not equivalent.
Yes,
we
absolutely.
have got no way of comparing the measurements from the Australian electronic probes that the bomb is using with the old mercury thermometers. They are, I think that at the very least one could suggest that they might be cheating a little bit to get these records.
I agree. So we have problems with climate modeling. They're too simplistic. You clearly are working on neural networks, which is absolutely where weather system modeling has to go, because simply from in the last few decades, we're well aware of the multivariate layering of climate forcing mechanisms. More are being revealed daily, and we talked earlier about Zarkova's work, the heartbeat of the sun, the changing magnetosphere. There are so many variables, Milankovitch, the moon, and on and on. We could simply talk forever, and we're wasting time not actually studying the real science. What's behind that?
Well, of course, if you're only interested in general circulation models and simulation modelling, the historical data, the data that's being collected right now across Australia doesn't really mean that much to you. But if you're into big data, which is the way of the new world, then the integrity of the measurements is paramount. So my team here, there's three of us, we were sort of thinking, well, it doesn't matter so much about this homogenization because it's not actually affecting the raw measurements. We just use the CDO data rather than the ACORN data for our arrays, but we've actually got problems now because we're realizing that there's problems with the actual measurements for Australia. And so, you know, if there's problems with the integrity of your raw data for individual series, including Rutherglen, it even makes it hard to apply these big data techniques to climate science. Now, it's not unsalvageable, and maybe we should just move to the states where you've got better data and start forecasting for you guys, but it is a concern because I agree with you. Big data neural networks is the way to go because there are these embedded cycles that do work from a forecasting perspective, but the integrity of the data is paramount, and we've got problems with that now in Australia.
Now we've been forecasting here for the last year, and I'm not a weather forecaster, and my work was in geologic time frames. You know, so I'm a field geologist that looked at tens of thousands of years in sedimentary rock layers, and we were comparing it to ice core data and other nested hierarchic models, including the Milankovitch hierarchy of cycles. But now the climate data that we have now, so the forecasting I've been doing, all I simply am looking at is the paleoclimatology data, the sunspot data, and the historic record of climate. And so I can put ourselves right now, today, at the bottom of solar cycle 24, and I know that cycle 16 and other cycles in our past, there was a similar place. And we're breaking the same records, and the same weather events are occurring that occurred back in those solar cycles with similar dynamics on Earth, similar total solar irradiance, similar solar cycle. And so we're absolutely able to predict weather based on past record events because history is repeating itself as a climate cycle.
And you would say that it's going to get cooler, and when it gets cooler, it actually gets drier. Would that be right?
Yeah, these are so. There's absolutely a cycle that I'm finding that's a drought deluge cycle that's around 11 years, 11.5. It could be the solar cycle. It could also be associated with the rotation of Jupiter. So we have a lot of work to do because you're well aware that the major gas giants play an integral role in climate cycles.
That's right. Jupiter and Saturn are significant. If you start looking at the 150-year, 400-year cycles.
Yeah. So, do you have any thoughts on those that you could share with our listeners? As far as one of the criticisms effects.
Okay, so one of the criticisms of our work with the neural networks has been that we don't look at the underlying mechanisms. We just let the neural networks forecast. And for a period until our lab was closed down at Central Queensland University, we were doing 1 month, 3 months, 6 months, 9 months, and 18 months forward rainfall forecast, not looking at underlying mechanisms, just feeding in sea surface temperature data, air pressure data, and historical rainfall and temperature data. And that was giving us a point source location rainfall forecast, which is not at all what you're talking about. Now, what John Abbott and I started doing a couple of years ago, because of frustrations with a few things, including the reliability of the daily temperature data, was start to decompose proxy records, which is more the sort of thing that you're perhaps interested in with the sunspot records. So we went and looked at the proxy data going back 1,000, 2,000 years, and what would happen if there hadn't been an industrial revolution. So we trained our data to 1830 and then let it project forward, and that's giving us a cooling into the immediate future, but we're not forecasting that far out, and we're not actually saying what the cause is, but it does maybe correlate quite nicely with your theories as they relate to sunspots.
Yeah, so what we are seeing now is a 0.6 degree cooling since 2016 with the Roy Spencer data from UAH satellite. And we predicted that there would be an increase in total mass of snow in the Northern Hemisphere for the next 3 years, each breaking the previous record year after year. And this year, in April 1st, we saw over 650 gigatons above average snowpack in the Northern Hemisphere, which is exceptionally off the multi-decadal chart average by 3 times. Now, that moisture is now in the subsurface or still in ice and snow and hasn't melted yet, which is why there are these massive droughts in the lower latitudes, because that moisture has been immediately eliminated from the water cycle this year. So that is a catastrophic event, and it causes wildfires and droughts. And this has been seen in other grand minimums and even small solar minimums like the Dalton. So as the inception of the Dalton and the cooling event happens, you have this quick, it doesn't seem to be cooling everywhere because it's a minor event globally, but you have the water locked up in snow sitting in the snowpack up high in the high latitudes, which is eliminated from the water cycle, causing droughts.
That's fascinating, and it's brave of you to make these projections just forecasts just a few years out, because you're going to be around to see whether they come true or not, which is how you test a theory, by making the forecast and seeing what happens. Of course, there has been a huge focus on ice at the Arctic and the Northern Hemisphere, because it's been trending in the other direction for so long. So you're saying that trend is reversing now?
Well, it reversed 2 years ago. In fact, the Arctic ice extent and the thickness currently. The Arctic ice volume is well above the last 3 or 4 years and is matching 1970s and 90s levels. And today, did you see in your part of the woods, all of a sudden this flurry of activity on the 3-time drop in Antarctic ice? Have you seen those headlines coming out today?
I gather our national newspaper, The Australian, has got something in there about ice melting at the Antarctic, but I haven't read the story. I know that there is a lot of regional variability, and that the Antarctic has been gaining ice for the last 30 to 40 years, but there was actually some big losses corresponding with the Super El Nino in 2016.
Yes.
Doesn't fit global warming theory, but there was a dramatic loss in ice that nobody could explain. And the fact that they hadn't been reporting on the gaining in ice previously made it a bit difficult for them to then report on the loss of ice. But what is fascinating is that the northern and southern hemisphere don't always match in terms of what's happening. There is a lot of regional variability.
Yeah, absolutely. And what we're finding is that it is corresponding to a definite cyclic variability that needs study. There are so many cycles affecting cycles that we need teams on both hemispheres with unadulterated data to start unraveling the facts. And the problem is that the reason I'm making these predictions and doing the science I'm doing is because I'm not associated with the university. I don't have a job in the field I need to hold. I am not beholden to anyone. I am now broadcasting from the middle of the woods next to the 416 fire near Durango in the South San Juan wilderness. So I don't have anything to lose, and I think the public has everything to gain by buying your book and to listening to our channel, because the facts about science and climate is being polluted by the mainstream, and their goals are, and I don't know if they have goals, but they're controlled by just 6 multinational corporations, and therein lies the problem. Do you cover any of that in your book?
We don't really get into what I would call the energy politics and the global politics. The last chapter is by a fellow called Clive James. I'm not sure if he's so well known in the States. He's very well known in Australia and the UK. Have you heard of Clive James?
Are you asking me?
Yeah.
Yeah, absolutely.
Okay, so he used to be on BBC television, and as he says in the final chapter to our book, I don't purport to know much about simulation modelling, but I do know a little bit about the abuse of language and poor journalism, and he doesn't quite say it, but real conspiracy theories. But he basically suggests that the house of cards is going to fall down. But actually, to read from the book, I've just got page 230 open. A house of cards collapses only with a sigh, and when it has finished collapsing, all the cards are still there. They've built this theory up. It's not proving useful in terms of weather forecasting or understanding anything very much, but they've used it to provide. In Australia, our electricity is becoming so expensive because of all the subsidies for wind and solar, and that's hurting poor people more than anybody else, and it's closing down local industries. So somebody's making money out of it. So the theory may not be holding up, but you've got all these these people who are saying, well, we've moved past the theory, and you still need to keep sponsoring these alternative energy systems. So there's obviously, and Clive really concludes in the chapter that that he can't see it all going away, even though there's nothing from a scientific perspective holding it up, and that the abuse of language is appalling. You know, the changing of the words to support the idea of catastrophe when the evidence just isn't there.
Oh, right. So let's stay there. So we have mainstream media spewing catastrophe nonsense, okay? And I'm going to take a quote from you, or some of your words, where you say that policies based on scientific evidence reveals how many of the potential policy responses to climate change are often wildly disproportionate compared to their cost. Now, if we just take global warming, the cost has been billions. This is the largest fraud perpetuated in modern history, to the tune of billions of dollars. And like you just said, it is hurting poor people now because of the subsidies for renewables, which, by the way, are not in any way cleaner than coal or anything else that you burn, because of the way they're disposing and the rare earth minerals and other things we can talk about. So this is a huge fraud, and the scapegoat is global warming. You can't sue them. So I think that's what they've made. They've made the scapegoat. Like, who is going to be responsible for the misappropriation of funds and the deaths and the suffering because of this nonsense?
It's going to be interesting to see what happens into the future. I really feel more comfortable rainfall forecasting than I do forecasting the politics. Certainly, it's often what you find is that people stop talking about something, for example, and they move on to something else. I think that if we could get some traction in terms of alternative and better systems of forecasting temperature and rainfall, and we could somehow get those forecasts to be reported in the mainstream media, you know, people have to start to realize that, you know, like last winter really was cold, and even though they said it wasn't, well, actually, I think that people are going to increasingly doubt some of these ridiculous catastrophic forecasts, and but at what point the money and the sectorial interests behind them give up, I don't know. I just can't see that happening. So, you know, we live in strange times, really, don't we?
Amazingly. Now, the historical documents and even economics groups like Armstrong Economics are well aware of these centennial crop failure cycles that drive the markets. This goes back to the times of Christ, and they have clear data on, let's just say, wheat that goes back to 1100 AD, and they know that these crop cycles are predictable, probably based on the sun, and the markets are based on the sun as well, and they follow solar cycles. So clearly, we need better rainfall forecasting to protect the general public from these crop loss periods, which result in famine, often global unrest, and historically the end of empires. And it's amazing that there are billions of people, I would say hundreds of millions, currently the masses, some refer to them as the sheeple. They think that there is government conspiracies, weather modification, chemtrails, and spraying operations, and that governments have the ability to control weather in such a way that they could create floods, and they're steering hurricanes. Now, this is all nonsense because they would actually be feeding the people in their countries and saving money if they could do this. Do you have any thoughts on the insanity that's being perpetrated with all the conspiracy theory? Is it just used to pollute the air and to continue the global warming nonsense, do you think?
I think that if we could better forecast drought and flood, we would know, agriculture would be so better off because we wouldn't plant when there wasn't going to be enough rain that season to get a good crop. So what we actually need are good forecasts, and they should be based on tools, on methods that have been shown to work in the past, so we have some confidence with them into the future. There's no evidence whatsoever that these general circulation models give us useful forecasts into the future. So I think that it's quite clear that from a practical perspective, current global warming theories failed us in terms of theory, in terms of tools. We need to move to something completely different, but there's huge resistance to that. In fact, there's active opposition to people like myself publishing and being able to establish at a university or with the Bureau of Meteorology, because just the concept that we still have natural climate cycles and that we can use big data techniques to forecast forward is something that so many people with vested interests that they're not in the community's long-term good. So, we're in a mess, really, from a whole lot of different perspectives, aren't we?
Diamond, would you mind if I jumped in? I had a question.
Please.
This is Scott. When you were talking about, needing better data and, how a lot of the data points are on devices that aren't consistent and how those devices are, even the data from them gets manipulated. How many devices would you need to necessarily have to get a good sample, to get as long as you knew the devices were consistent? Is it necessary for every city to have some type of device, or if you're trying to do global modeling, how many devices would you actually need?
I don't do global modelling. What we do is forecasting for a specific location, and we can forecast for locations where there's good historical rainfall and temperature data. But it is time-consuming, and it would be good if there was a team of us. We've tried to establish twice now at universities, and we've actively come up against resistance to. I mean, there is this idea, and the Bureau's basically said, don't go with pattern analysis and the use of natural cycles to forecast forward, because we have catastrophic anthropogenic global warming. The only thing that can be used now and into the future is general circulation models. Now, this is the sad state of affairs. We know general circulation models don't work, but they are what the mainstream climate science community knows how to run, has invested in, and they prop up this theory of climate change, which has value to an energy sector, and there you get into geopolitics, which I don't understand.
Mm-hmm. So, is there? Let's just say you confine it to Australia itself. I mean, if you wanted to have a good sampling of temperature locations, how many locations would you need?
So you're asking if we could forecast. Well, see, often what's happening in Western Australia is different to what's happening in, say, Southeastern Australia. You've got different weather systems which are having an effect. So if you're interested in monthly rainfall forecasting for a particular region, we can do that. We can do that already. And I think that's exceedingly valuable for management of dams for cities, for harvesting scheduling for farmers. We can do that already. That's something quite different to say forecasting global temperature change. We've shown in a paper that we published in the journal GeoRes-J last year how you can also use this technique for global temperature forecasting. So that's GeoRes-J, volume 14, pages 36 to 46. So the title of that paper is The Application of Machine Learning for Evaluating Anthropogenic versus Natural Climate Change. So we're showing the application of the technique. Data's not really the problem, but you need a team, and you can't, do Southern Hemisphere temperature forecasts at the same time that you're doing rainfall forecasts for Sydney. You need people dedicated to different tasks at different times. At the moment, there's been a great effort just stopping a team operating at all here in Australia. So that's all a bit sad. And of course, our forecasts aren't perfect, but we do. We have shown, and this is published in the peer-reviewed literature, that our forecasts are much better in terms of skill scores or quantified than anything that the Bureau of Meteorology is doing, than anything our BOM is doing. So we've benchmarked everything, and it's all published, and it's all there for people to scrutinise.
Mm-hmm. And just a quick question about are you still loading data into the neural net currently, or are you have you finished your research and you're not doing that now?
We are doing some of that, looking at forecasting La Niña and El Niño events, but we're not doing nearly as much as we were a couple of years ago. And I guess I have been a bit preoccupied. I was preoccupied editing the book, and fighting with the Bureau over how it's actually measuring temperatures at the moment, because we sort of feel that we've proven the technique and now we would like some support. But it's not, support just to say keep a couple of us going. We would actually like support to do this with the Bureau, or separately, but we really need millions of dollars, and we think that that's justified given that we've proven the technique. But the trouble is there are political implications that flow from our work, because if our technique works, and we've shown that it does, and we've published this in the scientific journals, then it means that the natural climate cycles are still dominating, and it means that anthropogenic global warming theory is nothing more than a failed theory. So there's a whole lot of politics associated with backing a relatively simple weather forecasting technique.
Yeah, and kind of one last point too is, I know that your neural net is very it's very clean in that it's looking at current data that you've loaded into it. But it'd be interesting if it were if there was another run that could be done that was where you introduced the longer term, the longer cyclical terms, we're, like we said, we're in a solar cycle 24 right now. I mean, it'd be interesting to just kind of, bounce the direction that your results are coming up with against where, if you had those same numbers, you could put the cycles, the sun cycles, in with the data that you have and merge it together in the neural net and see what it came up with.
There's so much that can be done, and that needs to be done, but it's a case of John Abbott and I actually doing this work, and it all takes time getting the arrays together. Moving, for example, I would love us to move from monthly, our data sets are monthly data sets, to daily data sets, but it's all exceedingly time consuming. We're not managers, we're the people that actually put the data together and run the arrays, and writing stuff up and sending it off to journals all takes time, and then when the journals say they want these changes and those changes, we've got manuscripts that still haven't been published for no good reason, really. So it's a case of us maybe being at the beginning of what perhaps in 20, 30, 40, 50 years' time is what everybody's going to be doing. I'm assuming that sooner or later our bomb has to move over to these, and it'll probably just happen in one big change of minister or something. There has to be an aligning of the politics with the science. At the moment, it's the tide's against us, but I don't think it's going to keep going out. It's going to have to change, but it may not even be in my lifetime. But it's going to change. By the way, I'm only 54. but it's amazing when the history of science would suggest that sometimes the obvious. It takes a long time for the mainstream to move to a different technique, to move to a different theory.
Right. I mean, before I retired and started helping out here with Diamond and so forth, I was working at a large defense company, and there I was in charge of the data warehousing for all their manufacturing. So I understand the big data, and I understand neural nets and that sort of thing. So it just you're right. You need some hardware. So
we've been running our networks off of gaming computers, and we use off-the-shelf neural dimension software. So what we've been doing from the perspective of machine learning and neural dimensions is not particularly clever, but the data we've been inputting, so nobody has applied that proven technique that's used in medical diagnostics, for example, to climate cycles, to rainfall forecasting. So what we've been doing that's different is the application of the technique rather than the technique. So we use off-the-shelf neural network software, and we use gaming computers. Though this can probably be better done with cloud technology, and I mean, there's a whole lot of things that we could do better. But what we think we've done and we've got published is just to show the application of a technique, and it can be, and we've shown specifically with respect to rainfall and point source locations, but that can be scaled to regions, and that can be moved over to temperatures, looking at decadal forecasts for southern hemisphere. But you're inputting different data. What we've spent some years working out are what are the key drivers of rainfall for the east coast of Australia, and particularly the northeast coast of Australia. And I suspect that forecasting rainfall for the northeast coast of Australia and the key drivers, so a neural network can only deal with so much data, so you don't feed it everything. You work out what is important to it, and then you let it find the patterns, build the models, and give you your forecast. If you were forecasting, for example, ice cover in the northern hemisphere, you'd be looking at putting different types of data arrays together, and your network configurations would probably be different again.
Yeah, the problem, Scott, all goes back to the fact that this all costs money, and with the sham 97% consensus believing that the world is burning up due to anthropogenic effects, the funding just isn't there for the scale of modeling that needs to be done. And like Jennifer talked about, it sometimes takes decades, up to 3 decades for these paradigm shifts to even occur, and we are just at the cusp of the paradigm shift. It's taken 3 decades for the global warming model to fail consistently, and now we're at a flexure point. Jennifer, can you talk about the nonsense of the 97% consensus? But more importantly, what we're seeing in the media and in science is that when scientists are on the cutting edge of this new science, grand solar minimum, heartbeat of the sun, plasma physics, climate cycles, all the realities and the new frontiers in science, all the mainstream has to say is, but global warming is going to negate all that.
I actually, I know people have written whole papers about how there is no 97% consensus on climate change. I actually don't get particularly excited about all of that. I get excited about temperature data and rainfall data, and the rawer it is, but the higher quality it is, if you like, the more excited I get. So I will spend days and weeks putting arrays of temperature data together and rainfall data together, and running that through neural networks. I know fundamentally that, for example, people say that it's getting hotter and hotter in Australia, but and that I understand that is the consensus position, and it's supported by our BOM and all these other institutions. I know that's the consensus position, but I know that all the people that talk about that data have never actually spent any time with it, whereas I've spent years with that data, and I know that's not what it actually says. I also know that the word consensus is not, it's got nothing to do with science. I mean, the concept of a consensus, it's a political concept. Consensus is about, it's about politics. Science is about evidence. Science is about testing theories. It's about making forecasts. It's about seeing if you are, how accurate you were with that forecast. When you make a rainfall forecast, you're never 100%, but it's about working out how accurate you were and how accurate you might be able to ever be in terms of a monthly forecast. So the term consensus and science, well, they shouldn't really be put together. The moment somebody says the science is settled and there is a consensus, you know that they're talking in the realms of politics, that they don't actually know very much about science.
So what is it about Al Gore that makes him so desirable?
I think that a lot of people find science difficult. Some people from a young age have an interest in natural history and have an interest in the world around them in terms of physical mechanisms and in terms of patterns and in terms of how it all works, whereas I think they're the minority. I think most people are much more interested in being on the side of the consensus and making money and being entertained. And I think for a brief period in our history, it was reason and for science, you do need institutions. Just talking about making these forecasts at the sort of scale that you would like, for the sort of regions that you would like, you really need that to happen with institutional support. And so you need to have a society, or you need to have people within your community and society that value science, that value evidence, and that understand that is much more mundane and quite different to something like Al Gore's Inconvenient Truth movie, which was not about science. It was about entertainment. It was about morality. We had a past Prime Minister here in Australia who talked about climate change being the greatest moral issue. Well, if you want to make it a moral issue, that's one thing, but don't expect to have good rainfall forecasts, because to have a theory and tools that give you good rainfall forecasts, that's something completely different.
So the state of science is settled. No, it isn't. But that's where we are, and that's an unfortunate state of affairs in the modern world. You talk about, you mentioned in the conclusion of your introduction, Clive James, and we're approaching the end of the show here. We only have about less than 10 minutes. So if you could give us a nice conclusion, where are you going from here? We know it's neural networks and predicting weather, and what is the Clive James conclusion?
Well, Clive basically, I think there's a chapter 8 by Jo Nova, which I think is a little bit funny. I laughed when I read Jo's chapter. She's got a lovely turn of phrase. Clive James's chapter is beautifully written, and it's amusing, and he takes a long historical perspective, and he sort of says that this obsession with catastrophic global warming's just a phase we're going through, and it's all going to pass, but it's probably not going to pass quickly, because there's so many people who are vested in it, but it will pass. So I guess we can feel a little bit positive that we're not stuck with this forever. I guess what I'm less confident about is that we are going to get back to strong institutions that are committed to evidence-based science, because this it's not just in climate science that there's a bit of a crisis. Actually, in chapter 1 of the book, Peter Ridd talks about the science quality assurance crisis not being limited to climate change, though I suspect climate science is we see perhaps the worst of it. But even in medical research, there's huge problems now with the reliability of science, and what's really needed is for mechanisms to be put in place that go beyond peer review. We need a culture that's committed to integrity of measurements and the publishing of data that has been. People say we need to just move beyond peer review, but if you are going to understand, for example, coral core calcification rates, you need people who have got expertise in that, and they need to be able to honestly spend time looking at what has been done and its scientific merit. And when there are problems, as Peter Ridd points out with some of the work published on the Great Barrier Reef, there needs to be mechanisms in place for those people who are, if you like, whistleblowers to be heard. And I think Scott Pruitt in the States has talked about the value of having red teams and blue teams. I mean, maybe science can learn a little bit from laws about evidence and the testing of evidence. Maybe we're going to have to go through this period where there's opportunity for alternate groups to be funded to scrutinize the evidence, and that gets back to some of the theories of how you get away from groupthink. And I think that Yanis Irving's written a whole book about that and the importance of moving away from groupthink if you're going to win wars. Of course, if you're going to win a war, you need to have respect for the enemy. You have to have military theory and plans that to some extent have been tested. And of course, also in terms of the winning of the Second World War, I think it was because your generals listened to the people who had the good weather forecasts, because of course the D-Day landing that was planned to occur on a full moon, when this brilliant British, it was the American generals who listened to this slightly eccentric British weather forecaster who said that there was going to be an opportunity, there'd be a clearing of the weather because of the lunar cycle, and he had a proven track record, and they actually set up the D-Day landing when there was going to be the appropriate weather, and the Germans thought that it was going to keep storming, and they got it wrong. So I mean, weather forecasting is not only important for dam management and scheduling of agricultural harvest, but it's also important in terms of winning wars. And I can tell you now that the Russians and the Chinese are going ahead with neural network forecasting and understanding solar cycles, while the West is potentially not going to be able to give good forecasts should we end up in a third world war.
Yeah, well, Jennifer, I want to thank you. I think geopolitically we're headed there, and I can't thank you enough. It was such a stimulating conversation. Guys, if you're listening and you're watching this rebroadcast, get the book. It's going to be a link below. It's Climate Change the Facts, 2017, edited by Jennifer Marohasy, our guest tonight. And I wish that it's as simple as you think, Jennifer, but I think that crony capitalism has taken over the globe. I think that the multinational corporations have become slightly more powerful than the actual governments, and they're running the narrative, and it is out of control. And I don't know what kind of mechanism we can develop to actually prevent real science from happening, because basically you have to be a whistleblower to be doing new theories or have new ideas, which is completely insane. That has nothing to do with science.
Well, you got to get rid of the grant system, you know.
Yeah, the grant system is now controlled by the multinational corporations who own the universities.
Mm-hmm.
So the problem is embedded in the crony capitalistic model, and I think without a global reset of some kind, it's certainly not going to be a global government that's going to get us any of the truth, because the narrative is being controlled to run the geopolitical scene. And those countries that are smart, like China and Russia, they're going into the historical record of grand solar minimums, the sun science, and other climate cycles, and they're looking for the truth, which is what you just mentioned, basically. And I think that the truth is a lot to swallow for the general public, so we're just being fed a narrative to keep the geopolitical story moving forward. And it may include world war. Who knows? But the point of this channel is for you to get the facts and the truth and the real science, and you have to do your homework, and that doesn't involve watching TV or mainstream media, because the television programs you're watching, the newspapers you're reading, and the mainstream media narrative is controlled by the very multinational corporations that are destroying science, and they're not allowing